Okay, now we're going to evaluate this f sub I dot delta s sub I. Okay, f sub I, you plug in your x of t function, your y of t, your z of t function, evaluated at t sub I, into this. Well, x of t sub I is ti star, so for every x you substitute ti star. And then for every y, again, since the y is just equal to t, y of t is equal to t, you substitute ti star for every y, and you do the same for every z. Again, if we had different functions here, it wouldn't be the same thing substituted. The only reason we're substituting t sub I star for every variable is this is the parameterization. It's this parameterization of the curve makes that work. Okay, so substituting ti star for every x, y, or z, we're going to get we're going to get ti star to the fifth here, because we got one ti star here, we got two of them here, it makes 5. We're going to have 5 of them here, we're going to have 5 of them here. So every one of these is going to be a 2t sub I to the fifth, which means that we can express this as 2t sub I to the fifth multiplied by I plus j plus k, because every one of these vectors, unit vectors, has a 2t sub I to the fifth as its coefficient. So right here are all the details of that, and then our delta s sub I is r prime of t sub I star times delta t sub I. Well, r prime, what's the derivative here? Derivative with respect to t is just I plus j plus k, and that's times our delta t sub I. So that finally our f sub I dot delta s sub I, and I can read you that, but it all comes from this. Ultimately that equals 2t sub I to the fifth times 3 delta t sub I. And of course we could make that 6t sub I star to the fifth times delta t sub I. And these t sub I should have stars on them, because we're still talking about the ith interval. And let's see, I've got stars on them here. It's the only place I missed one, okay? So then what do? If we want the total f dot delta s for the whole path, we're going to have to add this up for all the intervals. Now the value of t sub I star is going to be different for every interval. So we add all these up from I equals 1 to n, and then we take the limit as our delta t sub i's approach 0. Of course that's going to make n bigger and bigger, and in the limit we're going to end up with the integral. The integral of what? Well, f sub I delta s sub I is 6ti star to the fifth delta t sub I. Our delta t sub i's, by magic or by something you understand a little better than magic, approach delta dt's, and our t sub I stars approach t's. And we end up then with the integral of 6t to the fifth dt. And what are the limits on the integral? Well, integration is with respect to t. T goes from 0 to 1. That's the interval that we partitioned. Our partition goes from t equals 0 to t equals 1, so our integral goes from t equals 0 to t equals 1. So there's our result, 6t to the fifth dt, and you can easily evaluate that integral. You just get 1. Now next we're going to integrate from 1, 1, 1 to 1, 0, 0 along a straight line. That would correspond to going from here in a straight line to this point here. Okay, so and that path is almost parallel due to the perspective to this one. So I'm not going to attempt to draw it, but that's where we're going to go next. So you might think ahead. How would you set that up? We're going from 1, 1, 1 to 1, 0, 0 along a straight line. Okay, think through what we did here. How would you do what? What do you have to do? You have to describe the path. You have to partition. Then you have to find f dot delta s in a typical subinterval. Okay. That's all there is to it. And it just takes practice working through the details until it becomes second nature and begins to make more and more sense.